guys, how are you doing today? I hope you are all enjoying this new lesson. In our previous sessions we learned the universe and we learned some terminology related with the space science, and today we will go dig deeper related with the stars. So we will learn about how we are classifying stars, what are the different measurements related with the temperature or brightness of the stars, and we will learn a lot bit more about our famous star, Sun. So if you want to follow me from your book, like always, please open Module G, Unit 1, Lesson 2, pages between 16 and 24 will be our topic today. So let's remember what was the star. So basically a star is a large celestial body. So when we are saying that celestial bodies, they are all the objects in the space, okay? So it's a large object that is composed of gas, okay? Don't forget, in star we don't have solid rocky core. Stars are composed of gas and they are emitting light. Okay, most of them are made up of hydrogen and helium, but it's a detail for you. Also, they can contain some other elements. But what is most amazing related with stars, they are inside the core. Stars are always producing energy, and this energy is emitted by light. Okay, and they are this energy is really huge because it is as a result of nuclear reactions. Okay, not like as we know, not the energy as we know from our daily life. So we have different brightness for different stars, we have different colors for different stars, we have red stars or blue stars, and surprisingly red stars are the one who are cooler than blue stars. Blue stars are has higher temperatures. We will learn more related with this later. And our sun is in the middle. It's a yellow star. So probably you already know sun is a star. So it's a large celestial body made up of gas and emits light and other electromagnetic radiation. So most of the stars doesn't look like sun because they are millions of kilometers far away. We are seeing sun so big because it is the closest star to Earth, basically. So we have sun's energy, sun's gravity is really big. That's why it can control all the other planets and asteroids, meteoroids, dwarf planets, all the other objects around itself. We are all orbiting around star with other planets. So because it has a really powerful gravity force to pull other objects towards itself. So what's more related with stars, we have bigger sizes than sun, or smaller sized stars, and we have cluster of stars, multiple star systems. They are orbiting from each other at the same time. So this type of two or more systems that are made up of two or more stars are called as multiple star systems. So for example, here as an example in your book, they give us some different stars. For this blue star, this is a yellow star, we can say, and we know now that blue star is hotter than this yellow star. And now we have also here we have a multiple star system. So, and what else I would like to add related with sun. So it is really important that sun's core is really hot. The temperatures inside the core is really hot because it is where the reactions, production of energy is happening. But on the surface that we see, the temperature is 5,000 degrees Celsius. Yes, 5,000, more than 5,000 actually. I'm not reading the exact number, as you notice. So it is really hot, but like you see in this picture, the temperature of sun it is actually showing the ultraviolet radiation, but you can say that brighter places has higher temperature. On the other hand, the dimmer places has lower temperatures. So the temperature, even on the surface, the temperature is changing from place to place. But what you should know is it is really hot. It's a yellow star, and the produced energy inside the core escapes into space in form of visible light, right? We are seeing the light coming from the sun, or different radiation, heat, and wind. Yes, sun also can produce winds. So that's all for the sun and the stars. Up to now we learned the basics related with the stars and sun. Now we are going to learn more related with the brightness of stars. Okay, it may be a little bit confusing for you. I will try to explain it as much as clear, but just even if you can understand certain terminology, it will help us later. So, about the brightness of stars. When you look at the night sky, you may see some stars are looking really bright, but others are not looking that much dimmer. So we may have different reasons for this. And when scientists are talking about the luminosity, they are talking about the actual brightness of stars. So what does it mean, actual brightness? Luminosity doesn't depend on how far away the star is or how its light is coming toward us. Luminosity is the exact brightness of the star. It depends on how brightly, it depends on the energy of the star, how brightly the star is shining. Okay, it is the absolute exact brightness of the star. But from Earth, as observers, we have two different measurements for brightness of stars. First, I want to start with apparent magnitude. Okay, in English, apparent means visible. Okay, if I can see something, it is apparently, we say. Okay, just try to understand the words first. If you don't know the words, in order to understand the terminology, please check your dictionary. It will help you a lot if you don't know the meaning of the words. So apparent means visible. So the apparent magnitude of the star is measure of how brightly it seems to be. Okay, how brightly we see the stars. It is measured by just how the vision from Earth. Let's say we have two different stars like this, and we have from Earth, this girl is seeing these two stars in same brightness, right? We can say that she is seeing the stars in same brightness. But in reality, we know that this one is closer to Earth and this one is farther away, and because it is more further, we are seeing this star also in the same brightness as this, but in reality its luminosity is higher. Okay, what is with apparent magnitude, we have only the brightness from the Earth. Okay, So we also have something called as absolute magnitude. So it is the measure of how bright a star will be if the star were located at a standard distance. Let's say that I am just lining up the stars like this in the same distance. So I will have a standard distance for all stars. So each absolute magnitude will also be their apparent magnitude when I line these stars like this. So absolute magnitudes are only related with their are giving us their exact brightness, the star's exact brightness. Okay, and because the stars are located in different distances, obviously we are not able to see how bright one star from another. So astronomers calculate the absolute magnitude of each star just by comparing their apparent magnitude and their distance. So we can know how far away a star is, and we can know how we can compare the brightnesses of different stars in order to understand their brightness. I hope that I am clear. So let me repeat from also here. So in order to understand the absolute magnitude, we should know the distance from Earth. Okay, so also we have another example like this from here. Let's say that this girl, you are over this tent, and this girl is coming towards you with a light. So the light is not changing, but from here, from this distance, from 20 meters away, the light seems dimmer. On the other hand, when it is closer, you are seeing her flashlight brighter. So distance is affecting how we are seeing the brightness of the stars, but the absolute magnitude can be calculated by looking at the distance from the tent, and the luminosity will be the actual brightness of the flashlight. Okay, I hope you are good on this. So another simple property related with stars, what is this? The surface temperatures. Okay, so stars have, we said at the beginning of the class, stars can have different colors, and these different colors are related with their temperatures. So for example, here we have a steel bar, and it is glowing red when it is around 600 degrees Celsius. When I increase the temperature of this steel, it is turning into yellow. When I increase it more, it is turning into white. Okay, so it is from red to white. Also you can see from here, from red to white, or blue-white colors. It means that the temperature of the stars are increasing. So please don't confuse. The red stars are the coolest stars, okay? They are the stars who are blue are the ones that has the highest temperatures. Please don't confuse with this picture that I show you about the sun. It is an ultraviolet image, okay? It is not a blue star. I will show you a blue star later. So we also have different sizes related with stars. Let me say that we are using sun as the measurement. So smaller than sun are called as white dwarfs. Okay, they are as big as Earth. very large stars, 10 or 100 times larger than Sun, they are called giant stars. And we see supergiants rarely, but they are 1000 times bigger than Sun. Okay, we have three different classifications. It's simple. So let's summarize from here. We have different measurements, different stars, different sizes. So in here you will see one dot. So this dot is representing the Sun. Sun is a yellow star. That's why its temperature is between 5000 and 6000 degrees Celsius. You can see from this table. Okay, yellow star. If you are seeing yellow in the color, just put yellow star, simple. So here this is yellow, red and white. Okay, yellow star 5600 degree. So we know the exact approximate temperature of the Sun. That's why I wrote 5500 degrees Celsius. We have a giant star here, a blue giant. It is bigger than Earth. I'm sorry, bigger than Sun. And this blue giant, it is asking for us the temperature. So we know that temperatures are getting higher as the color is turning towards the blue. So it is the highest temperature on the scale. It is probably more than 25,000 degrees Celsius. And we also have a supergiant here, even bigger than this blue giant. Okay, that's why we are calling it supergiant. But being super big, being biggest star, doesn't give you a clearance that it will be also the hottest star. Okay, size and temperature are not related at all. So we have dwarfs, for example, but they are blue. Like we have supergiant stars, but they are really cold when it compared to the others. It is below 3000 degrees Celsius. So it is the coldest star. The red one is the coldest star, but it is the biggest star at the same time. Okay. So, for example, if you were able to compare them by their color, the red one will be hot, obviously, but the yellow one will be hotter and the blue one will be hottest. And that's enough for today. Thank you for listening. I hope that you are all clear about stars. Please don't forget that stars are producing energy, and they have different distances. We have millions, trillions of stars in our galaxy, and they have different colors depending on their temperatures, and they can have different brightness, but we can measure their brightness by using absolute magnitude or apparent magnitude, as we say. Our Sun is the only star in our solar system, and it is a yellow star. It is not it is relatively cool. It is not that hot. And also what we learned, yes, we have three different sizes. If a star is smaller than Sun, it is called as dwarf. If it is really big than Sun, we call it giant. If it is bigger than even giants, we call them supergiants. That's all. So please revise what we learned today from your book also, and see you in the next session. Thanks a lot.